Hello, this is Johannes from PlanetScale Solutions Engineering team, and today I'd like to show you how you can visualize thousands of parallel connections to our serverless database, as well as how you can perform non-blocking schema changes. Non-blocking schema changes are trivial if your database is empty or if there's not lots of activity going on, because then they will just take a couple of milliseconds. However, if you want to change the structure of your database and there's a lot of production traffic going on with a lot of connections at the same time, it's not trivial anymore. Then you would need deploy requests from PlanetScale that make sure that all of those changes are performed asynchronously, and once ready, there will be a cutover and none of your production traffic is actually affected by all of this. This all sounds nice, but it's quite interesting and challenging to actually visualize that and get the timing right. And this demo is basically a pre-configured GitHub repository with GitHub Codespaces and GitHub Actions so that you can do those kind of experiments by your own or just follow along this demo whenever you like to. As said, there's action-based examples, so you can just do any step of the demo by following the steps along. And for instance, first create a database, then launch the visualization GUI and so on. Or you do the same thing with Codespaces, which is what this demo today will mostly be about. The reason I'm using Codespaces here is that they already come pre-configured with all the necessary tools, and I can also decide about the machine specs, like for demos where there's real production traffic or similar to production traffic going on, for non-blocking schema changes to be non-trivial, I would recommend to have at least an 8-core machine. 16-core might even be better to get really tens of thousands of connections and a realistic scenario. All the steps how to set this up are documented in the repository. There's also a public open source version of it called Jonico Matrix Demo with all documentation included. So if you wanted to follow along or have ideas how to improve our documentation or add your own demos, please do so. There's really everything explained step by step, including how to set up credentials, how to set up code spaces, how to set up actions. And we are very much looking forward to your feedback already. But without any further ado, I would just like to start into the demo based on code spaces. And that can be done basically clicking on the code tab and then as next thing on new code space. Enjoy. A Codespace is an integrated development environment based on Visual Studio Code with terminals and all the plugins you want, which means that it can run directly in the region where also our databases are running. The cool thing then there's not a lot of latency. Many of those demos, especially around performance, they require a very low latency, and this is guaranteed with those environments over here. The other nice thing about those environments is that we can collaborate with each other and that it's also possible to have a web UI for anything visualization like. So what you can see on the right hand side here, this is a web-based VNC browser with which you can actually run any application you want, like a browser or a specialized visualization GUI for those demos inside your browser. The way how you could actually get to this built-in desktop is by clicking on the support section that opens. Then there's the second entry here about the web VNC browser. You just click on that icon here, and then the password is always VS Code, and then you basically have any kind of development environment you want, or any kind of browser. You could even launch Chrome or a terminal if you wanted to. So to test anything which is very close to the actual database you want to test. So there was a lot of pretext, let's actually jump into those demo and find out what we actually want to show, right? So what you can see here is what we call the PlanetScale visualization GUI, and it can be launched in this by just basically doing a click, and then it automatically launches. The detailed steps are all described in the repository. The visualization GUI is a way to show any kind of database connections to our PlanetScale database, demo database, which are currently streaming any data in. So any updates will be visualized in form of pixels. So the underlying table structure for that one is actually a pixel matrix. Think about it like a picture. It has separate compartments called cells. So there's 192 cells by default, 16 times 12 cells. And the idea of those cells is that when we are now booting up many of those different database connections or processes, each of those processes will get an individual cell and an individual worker, so that we can see updates from many parallel connections at the same time. To make this less abstract, let's go to the PlanetScale console and check what is currently in that matrix. It's already pre-populated. That database, it has 84,000 rows as we speak, and we can also have a look into the pixel format at the moment. So you can see there's a primary key, then there's an environment so that we can do demos in parallel, don't step on each other's feet. And there's this cellish thing. So that basically means the data here, the pixel data, for instance, would correspond to cell 14 and row 9, and the 9, the last one, says this is the first line of that for a particular cell. So the main purpose here really is to see if once things start to move, that this is from multiple processes, and then there's a constant stream of data. So let's get this constant stream of data flowing with the first demo. That first demo is actually just about showing that there's multiple parallel connections possible, and that we support many of them. For that, I'm starting the first demo script, which is start parallel connection test. And what this is doing now is to spin up 192 different Docker containers that will actually start streaming data in. So you can now see that those processes are updating the pixel metrics, and there's another process which is at the same time streaming the output. If you want to understand this in more detail, this is basically the code which is executed 192 times, and then with multiple connections in parallel to update by inserting into the pixel matrix. And the visualization GUI on the right hand side, it's at the same time also reading that data out with a select statement, 500 of those rows at a time. And then you can see that it's currently updating quite fast. If we went into the query view of our platform, you can also see the insertion is done quite often from many different connections. And there's then one process, the visualization GUI, which is actually reading all of this out, right? And returning those rows quite fast. When we now go to the specific database in question, we can also see that there's now many connections booting up to actually connect to the database. And if we were to go into our second Codespace, which we just started at the beginning and would run the same command there, we could get even more of those coming up. So if you wanted to demo, for instance, or test how many connections our free tier would support, just boot up multiple code spaces and just run the same command over and over again and see how the number of connections jumps here, for instance, to 16,000 or even higher. So that's the first demo, basically showing that our database supports many, many parallel connections. In the most drastic case, we could actually dedicate one connection for each pixel over here, so that we are going in the millions of connections. It's a quite expensive showcase. For the free tier, we typically say that 16,000 connections is basically what our default configuration can currently handle in parallel, right? And if I'm updating stuff here, you also see it takes a little bit of time before the connection count will actually get reflected over here. So that's demo number one. Demo number two is, while all of those pixels are streaming in, can we actually change that application? Can we make a schema change? And while doing that schema change, still see how data is basically streamed into that platform and is not blocking. That is the idea of non-blocking schema changes. Anybody still writing to that database will still be able to write, whereas at the same time, we are already adding new columns, for instance. And what we would actually like to add is a operations column to the database. I'm just showing it from a previous example where we already staged that one. It's a schema change that is adding an operations column, and what this operations column should actually do in that pixel metrics is to tell the program that if a certain worker connects here and streams pixels, that their pixels should stay there forever, meaning they will be pinned. So there's an operation where you can say, if I'm updating anything in this metrics, for instance, change the color of the PlanetScale logo, then those kind of pixels will stay there forever, even if some other worker is inserting rows for the same cell. The operation is called pinned, and there we can add additional operations to it. The main purpose really is to just have something that shows how to do a schema change, and at the same time still seeing changes over here without any blocking. So let's go back to our Codespace and actually create a second terminal. And from there, we are running another script, which is called add operations column and index. So what this is basically doing is creating a feature branch where this particular operation, in order to add the operations column, will be added. You see, when we create a new feature branch, it's not immediately there because we need to provision a new vtablet or multiple vtablets there, but typically it's done in maybe 20 seconds. And once it's there, we will also create a deploy request, and that deploy request we can then either merge from the web UI, or we can merge this with another script here, which was built for the demo application. Yeah, while this is running, as you can see, there's still pixel changes over here. So the database is under heavy load with more than 4,000 active connections, but it's still streaming stuff in. And here we go. We do have our new deploy request. Deploy request 24. If we check this one out, it will actually look very similar to the ones I've already shown before, with the operation column being added, or should be added, right? This hasn't been merged yet, right? This is something we will do, but before we do that, I will just not revert this, but restart this particular application here. The purpose of this is that the visual contrast is even more stark if we start it right now, and then we see pixels streaming in. And then we will actually merge this in the background. And while we are merging the pull request in, or the deploy request in, you will still see that this one is updating all the time. So let's do that. We will actually do the merge directly from here, from the web UI. Say add changes to deploy queue. So while there's a lot of data still coming in and streaming, our change is being deployed, and you won't see any kind of, well, slowing down at this point in time, right? So this is the power of non-blocking schema changes. Your production database will still work with anybody still assuming the old schema, and you don't get into a situation where everything gets stuck and frozen and well, you're blocked. Right? That's the main purpose of the demo to show over here. I hope that while this is deploying, we can also see that the connection count already increased now in the web UI as well. So there's still more than 1,900 workers constantly streaming in pixels over here. And I have to do something about this timeout, that I don't always have to add the credentials back there again. Let's have a look at the deploy request, how it's doing from this status perspective. It says 6 minutes and 34 seconds remaining. The reason why it takes that long is probably because there's just so many data rows still streaming in. I will just check how many of them are actually in, how many rows we're currently talking about. Just counting how many rows actually would have to be migrated at the moment. Yeah, it's more than 263,000 rows, which would be adjusted for the schema, and there's just constantly also rows being added to it. That explains why the non-blocking schema change is not an immediate operation, but that's also a purpose of any kind of demo, I guess. Going back to our progress, you see we're already at 23%. We could also see that, yeah, at the moment there's still many of them streaming data in. Both of the code spaces we launched are still busy streaming those data points in. And here you can see one of them just finishing their job, right? So we will have less load on the database in a second, or when those are actually finished. And then also the schema migration will probably finishing faster than 6 minutes. That's the thing about live demos. You never know exactly how long it will take. And I guess for a demo in front of a customer, you would have less data at the beginning, less preceded data, so that it does not take 5 minutes for this particular thing to be finished. Okay, so now half of the connections which have been pointed towards the database have already finished. The other ones are still streaming stuff. So I guess this will also have some effect on how fast the schema migration will be. Yeah, it's actually done. So what we can now do is tell this application that is still receiving changes that it now should go to the advanced schema. So it now should use the new operation columns and know how to pin pixels and not overwrite them. So I'm clicking on use advanced schema over here and then go to my Codespace and actually make use of this advanced schema one. Just saying start advanced schema stream. And what this will do is spawning new workers to connect to the database again. And this time using the operation column with the value pinned so that we will hopefully see changes soon that actually have some orange color, add some orange color to the PlanetScale logo while the rest is still being updated. Let's go to the database console and just say select star from pixel metrics where operation equals pin and see whether there's already data streamed there. And here we go, there you see stuff which is already using the new operation. And this should also be picked up by the web UI once all the pixels before have been addressed. Here we go. Now finally, these streaming changes are actually coming in. So now you can see that there's updates coming in that are already making use of the new schema. It should say PlanetScale non-blocking schema changes work like a charm in PlanetScale DB. And that is actually the end of the non-blocking schema changes demo. What we will now do is just revert that change. So basically removing the particular column, the operations column again. And we can do this from our command line again. We would say remove operation column index sh, and this time we are also merging the deploy request that goes with it as part of the demo flow from the console and not from the web UI. So this is now creating a new feature branch, remove operation column and index, which is basically reverting the particular deletion column. And once this database for the remove operation column and index branch is created, we will create the deploy request and then with that script also make sure that it's being deployed. And again, also deployment is an asynchronous process. So once we approve the removal of that operation, the script will also check whether it's merged yet or how long it will still take, reports on the progress. And once it's merged, this UI will also close because it basically means that we don't have the column anymore, and at the moment this application is requesting that column. So unless we switch back to the basic schema with a right click, you wouldn't be able to use that. So it will just be a test that once this is done, we will also see the application shutting down. You can also have a look at this from the web UI, seeing how long it will actually take to deploy the change. Goes began deploying these changes, and it seems that's done because here it's already closed and now it's completed. Yeah, that concludes the demo. We have the plan to have multiple demos, not just about non-blocking schema changes, but also, for instance, about sharding coming up. Feel free to add your own demos over here. Feel free to change them. Also, all of the screenshots or the pictures can be changed to your liking, right? There's just configuration files in it where you would, for instance, use different start and finish pictures, where you can say how often things are repeated. I'm very much looking forward to your feedback, your pull requests, your ideas, how to make those demos well, more understandable. And I hope it's useful also from the Codespace's perspective to demonstrate something with low latency to our databases. Thank you so much. Bye.